Okay, in this video I want to go over the efficient level of emissions. And the efficient level is what economists typically call the socially optimal level. And, throughout we've been talking about externalities, in this case negative externalities, and the kind of example to keep in mind is fossil fuel use, all right, which are going to release greenhouse gases and other things as well. But greenhouse gases and the tie to climate change is kind of at the forefront. And so we're going to be looking at a market, stylized market for gasoline. And gasoline, of course, being a fossil fuel, we're going to be releasing carbon emissions and other emissions as well, but greenhouse gases into the atmosphere, contributing to climate change. And so there are benefits to using gasoline, of course, on the consumer side. There are costs that the producers incur in production and sales. And then there are going to be these external costs. And when we account for those external costs, along with the private costs and along with the benefits, we have a full picture. And efficiency, or the social optimum, is where those marginal costs and marginal benefits are going to intersect. So let's kind of draw our simple diagram of our market. And again, I'm going to say we're looking at gasoline as just a consumption good we're all kind of familiar with. It's not that we care necessarily about gasoline. It's kind of indirect because what we care about are emissions. And so I could be putting just emissions on this horizontal axis, but as long as we keep in mind that there's going to be a functional relationship between gasoline and emissions, that we're kind of use these interchangeably. We're going to have monetary values up here. And we would start with a demand curve, right? Consumers' market demand for gasoline. And we know that we can think about demand, market demand, as the willingness to pay, the marginal willingness to pay, right? These are the benefits. And those are the values that people are willing to pay at each quantity. Okay, then we have our supply curve. I'll just bring it up through here, through the origin. And I'll first label this as market supply. But we also know that market supply is encapsulates, or captures rather, the marginal cost to these producing firms. And so we're going to go ahead and put a little bit more detail in there, in the sense we're going to call it the private marginal cost, right? It's not like we always do that when we're talking about the supply curve, but we're going to have an external cost, we're going to have another cost, so I want to make sure that we can distinguish between the two. And in a regular kind of market situation, we'd think that the quantity, and I'm going to call that capital N for kind of unregulated market, and we would have that price. Okay. Now, I'm going to clean up this graph a little bit. We know what the price would be in the intersection of the market supply and demand curve, but we're going to have additional elements to this graph, so I want to keep it tidy. And so there we are. Now, with market for gasoline, market for fossil fuels, more generally, resulting in emissions, there's an external cost, right? The whole reason that we're interested in this issue is that this market allocation, or unregulated market allocation, is going to be inefficient, or could be inefficient. So let's take out this blue. I'm colorblind, but it says blue, looks blue. So we'll call it blue. And we're going to add to this graph by putting in that external cost. And let's just kind of blast this through up here. And we are going to call this the social marginal cost. I'm going all caps for some reason. Cost curve. Can we see that? We can't see that. Change of plans, right? Change of plans with this line. Let's see how the yellow looks much better, much better. Social marginal cost. And the social marginal cost, right, includes the private marginal cost. It does include that, private MC, plus, right, and here's an important point, the external marginal cost. Okay, the external cost. No. We're learning the light board as we go. It's fun. It's a good time. We just snuck it in there. The external marginal cost. And this line here captures everything. What the private firms are facing and what the external costs are. And that's this gap in between these two lines throughout. I'll go erase this again, just making my life hard. But that gap between those two lines is the negative externality, the external cost borne by others, right? By our innocent bystanders. Maybe they're not so innocent, but they're external to this market transaction, as we typically think of it. In this intersection, where the demand curve, right, the benefit of consuming the gasoline or fossil fuels more generally, and then the costs, right, incorporating both, that intersection is what economists would call the efficient level. And that's really the point of environmental policy, regulation, even if it's voluntary and not necessarily top down, is how can we get there? And if we put the price in, again, I'm going to take it away, but remember PM was, somewhere here where the unregulated market demand and supply intersect. Efficiencies were going to require the price of gasoline to increase and the quantity bought and sold on the market to decrease. And if we look at what the potential gains are here, it's important to think, okay, well, let's say we didn't do any sort of regulation. We didn't change from our market outcome. Well, if we expand this vertical kind of dotted line up to where the true marginal cost is, we can see that the social marginal cost exceeds the marginal benefit or demand, right, by this gap here. And so we want to be closer, or we want to be at the efficient level. And so this represents the gains that can be achieved, right, through environmental regulation or through reducing emissions to the efficient level. All right? So you can see a triangle like this. In taxation, we usually talk about this as a deadweight loss. But it's also a deadweight loss here. And the loss isn't because of a distortionary tax or something. The loss here is that we're emitting too much because the costs of those emissions at the margin exceed the benefit. And to be efficient, we need to ratchet it down to this point, right? So this triangle represents the gains to be made, or possible gains, right, from regulating the environment or regulating pollution, emissions, however we want to call it. And again, regulating can take on all kinds of different forms that we'll get into, whether that's command and control, whether that's taxation, permits, subsidies, whether it's not even formally regulation, but some sort of voluntary agreement. It's some activity that's kind of changing the rules, right? Changing the status quo from the QM to the Q star. And that triangle is important because that's what we're talking about, right? When we're talking about the social cost of carbon, right, which finds its way into EPA regulations, into cost-benefit analyses, the social cost of carbon is talking about this, right? It's that we're using maybe slightly different language, but when we account for, internalize the external costs, not just the private costs, but when we look at those external, it's going to require the quantity of emissions to go down and the price of this emissions generating good to go up. I'm going to pause there, and I'll come back with a welfare analysis to illustrate the gains from QM to Q star in a different way.